In the summer of 1998, a scientist named Stanley Ambrose published an idea that was as elegant as it was unsettling. He was an anthropologist at the University of Illinois, and he had spent years staring at two facts that did not, on their own, seem to belong together. The first came from genetics. When we compare the genes of every living human being, a person from Sweden, a person from Korea, a person from Nigeria, we find something strange. We are almost identical. As a species, we carry far less genetic variation than a single troop of chimpanzees living on one hillside in Africa. Two chimps from neighboring valleys can differ from each other more than two humans from opposite ends of the planet. Something in our deep past squeezed the whole of humanity through a narrow gate, a moment when the breeding population may have fallen to just a few thousand people, and everyone alive today came out the other side of it. The second fact came from the ground. Roughly 74,000 years ago, a volcano on the island of Sumatra called Toba erupted with a force the planet has not matched since, and Ambrose noticed that the timing of that eruption sat suspiciously close to the moment the genes seemed to point at. So he set the two facts side by side and asked a simple, chilling question. What if they were the same event? What if that volcano nearly wiped us out, and every human being now walking the earth is descended from the frightened handful who made it through the dark that followed? It was a beautiful idea. It explained the genes, it explained the volcano, it explained, in one stroke, why we are all so alike. It moved into the textbooks and the TV documentaries under a name that stuck, the Toba catastrophe, and it was taught more or less as established fact for the next 20 years. And it is worth being honest about why an idea like that spreads so fast. There is something in us that reaches for the apocalypse. A story where we nearly died and clawed our way back from the brink gives our whole existence a kind of weight and meaning. It makes survivors of us. A near extinction is simply a better story than a slow, ordinary success. And this one had a real volcano and real numbers behind it, which made it feel less like a story and more like a discovery. That pull matters because it is exactly the kind of pull that can carry an idea past the point the evidence can support. And then, slowly and quietly, that evidence began to take it apart. This is the story of a disaster we were certain had happened, and of the patient, unglamorous work that unhappened it. By every part of the theory, we should not have survived that winter. The trouble is, we did. Number 5. The eruption that really happened. Start with the one part of this story that nobody argues about, because it anchors everything that follows. The volcano was real, and its scale is almost impossible to hold in the mind. Around 74,000 years ago, a date pinned down by the geologist Michael Story and his colleagues in 2012 using radioactive decay in the crystals of the ash to within a few centuries, Toba erupted in the largest volcanic event anywhere on Earth in the last 2 million years. Not the largest in recorded history, the largest since a time before our species fully existed. The figures barely fit inside ordinary comparison. Geologists estimate it threw out something on the order of 2,800 cubic kilometers of rock and ash, many thousands of times the material that tore the top off Mount St. Helens in 1980. It sits at the very top of the volcanic scale, a magnitude 8, the step we reserve for the word supervolcano. Ash from Toba has been identified blanketing South Asia, in some places settling several inches deep across the whole Indian subcontinent, drifting as a fine gray powder over tens of millions of square kilometers of land and sea. The crater it collapsed into is now a lake on Sumatra, roughly 100 kilometers long and 30 wide, a hole in the earth you can see from space. Geologists gave the ash layer its own dry official name, the youngest Toba tuff, and they can trace it in seabed cores from the Arabian Sea to the South China Sea. Close to the volcano, the destruction needs no argument at all. Rivers of superheated gas and rock would have scoured the landscape for hundreds of kilometers in every direction, and nothing living in that zone survived. On the scale of the island, and probably the region, this was as close to the end of the world as the ground can record. So the eruption is not the mystery Toba happened. It was genuinely colossal, and Stanley Ambrose was entirely right to call it the largest explosive eruption of its age. Every solid thing in this story rests on that single fact, and none of what follows disputes it. The eruption is not in doubt. What is in doubt is what all that ash and sulfur actually did to the living world, and that is exactly where the certainty runs out. Number 4. The theory that explained everything here is the mechanism Ambrose proposed, and it is worth laying out carefully because the strength of the idea is the whole reason it lasted. An eruption on this scale does not simply bury the ground nearby. It fires sulfur gas high into the stratosphere, far above the weather, where it spreads into a fine haze that wraps the entire planet and dims the sunlight reaching the surface. That dimming, Ambrose argued, would have triggered what volcanologists call a volcanic winter, a run of years with cold summers, failing plant growth, and food chains buckling from the bottom up. And Toba's winter would have landed on a world that was already sliding into an ice age, already cold, already under strain. Writing in the Journal of Human Evolution in 1998, Ambrose proposed that this stacked cold could have destroyed most human populations across the Old World, sparing only small bands hidden in warm tropical refuges. Those few survivors were the narrow gate, the bottleneck the genetics seemed to be crying out for. And because the survivors were few and scattered into isolated pockets, their descendants drifted apart quickly in the generations after, which in his model was why the living branches of humanity look the way they do today. Sit with how much that one idea did. A single volcano now accounted for three completely separate mysteries at once: the vast ash layer in the rock, the crash written into our genes, and the shape of the entire human family tree. Ambrose set it inside a wider picture some researchers called the weak Garden of Eden, a small ancestral source, then a brutal squeeze, then an explosion of growth and spread once the pressure lifted. The bottleneck number that got quoted was startling in its own right. A global breeding population, perhaps as low as a few thousand, at most some tens of thousands, for the entire species, put a whole planet of humanity into a figure that would barely fill a stadium, and you have a hook no textbook could resist. In science, an explanation that neat is intoxicating. It is also quietly a warning, because two dramatic facts landing near the same moment in deep time is a coincidence first, and a cause only if the evidence goes and earns it. One event explained everything. And for 20 years, few people pushed hard on whether it had earned it. To do that, we could not sit and argue at a desk. We had to go to the places where the ash actually fell, and dig into the dirt underneath it. Number 3. The tools in the ash in southern India. At a site called Jwalapuram, the Toba ash lies thick in the ground, a pale band in places more than a couple of meters deep, that a person can walk up to and press a hand against. This is not the faint outer edge of the eruption. This is close enough that if a volcanic winter killed anyone at all, the people living on this spot should have been among the first to go. In 2007, the archaeologist Michael Petraglia and his colleagues published their excavation of that site in the journal Science. They dug down through the ash layer, and beneath it they found stone tools. Then they dug above it and found stone tools there too. And the tools on both sides belong to the same tradition, struck the same way, from the same materials, by people working stone in the same style. Whoever had been living under that volcano in the years before it erupted was, by every sign in the ground, still living in the very same place in the years after, making the very same tools their parents had made. Petraglia's team argued that this was not just survival but continuity, a way of life carried across the single most violent geological event of the era without a visible break. If a global winter had truly emptied the interior of a continent, this valley, buried under meters of Toba's own ash, is one of the last places on Earth where you would expect to find people calmly carrying on. They never left. Now, the honest caution matters, and Petraglia's own critics raised it at the time. This is one valley. It is possible that this particular community simply got lucky that they happened to sit in a local pocket. The winter spared, and there was a second argument, still unsettled, about exactly which kind of human made those tools. A single site where people carried on cannot by itself prove that people carried on everywhere. The Toba theory was never going to fall on one excavation in one Indian valley. But then a coastline on the far side of the Indian Ocean filled in the rest of the picture. Number 2, the coast that thrived at Pinnacle Point. On the southern shore of South Africa, near the town of Mossel Bay, a cluster of caves above the sea held human beings for tens of thousands of years. The people there ate shellfish. They treated stone with fire to make it easier to work. They left behind the layered residue of an ordinary, ongoing life. And in 2018, a team led by the geologist Eugene Smith and the archaeologist Curtis Marian published a striking result in the journal Nature. They found Toba itself in the floor of the cave, not a thick gray ash bed this time, but microscopic shards of volcanic glass, far too small to see, each one chemically fingerprinted and traced back across the Indian Ocean to the Sumatran eruption. Those shards did something precious. They pinned the exact moment of the catastrophe into the sediment, so the team knew precisely which layer was the disaster. And then they looked at how people had lived on either side of that layer. Above it, within it, and below it, they counted more than 400,000 human artifacts, heat-treated stone blades, the shells of countless meals, the ash of hearths burned one evening at a time. The occupation did not thin out after the eruption. If anything, the signs of life grew richer. These were not people barely clinging on. Heat-treating stone to improve it is a planned, multi-step craft. Harvesting the shore on a schedule is knowledge passed down and refined. The layers above the Toba glass show that behavior continuing and deepening exactly when the catastrophe theory predicted a population on the edge of vanishing. Curtis Moran had spent much of his career arguing that this coast was one of the cradles where modern human behavior was forged, and the Toba shards let his team test that story against the supposed disaster directly. They thrived. And again, the fair objection has to be said out loud. Pinnacle Point is a mild, food-rich coastal refuge, exactly the kind of sheltered place Ambrose's own model predicted might pull through. A thriving coast in South Africa does not by itself prove that the dry interior of the continent stayed warm. To settle that, we needed something better than any single dig. We needed a place that had been quietly recording the temperature, season after season, right through the event, and keeping the record. Number 1. The lake that never got cold in East Africa lies Lake Malawi, a deep tropical lake whose bed collects fine sediment layer on layer, season after season, like the pages of a book. Read the pages in order, and we are reading the local climate almost year by year. How warm the surface ran, how the water mixed, what lived and died in it. If a volcanic winter had ever gripped East Africa, this lake could not have hidden it. A sudden chill cools the surface. The warm upper water and cold deep water turn over and mix, and the chemistry of the mud lurches in a way that is unmistakable centuries later. A lake like this is a thermometer that keeps its own diary. In 2013, Christine Lane, Ben Chorn, and Thomas Johnson published their reading of a Lake Malawi core in the Proceedings of the National Academy of Sciences. They did the crucial thing first. They found Toba inside the core. The same microscopic glass shards chemically matched to the eruption, pinning the precise moment of the super eruption into the mud. So there could be no argument about timing. They were certain they were looking at the right page. Then they read the sediment on both sides of that page, layer by fine layer, at almost annual resolution. And the lake showed them nothing. No overturn of the water column, no swing in temperature, no collapse in the life of the lake. The mud laid down in the years right after the largest eruption in 2 million years looked essentially identical to the mud laid down in the calm years before it. The one place on Earth best equipped to record the catastrophe had recorded an ordinary run of seasons. The lake stayed calm, and the ground was shifting under the theory from another direction at the same time. When climate scientists went back and rebuilt the eruption's effects using better measurements, they found that the earliest models, the ones the catastrophe theory had leaned on, had badly overestimated how much sulfur Toba actually lofted into the stratosphere. The veil over the sun was thinner than the story required. The winter, wherever it happened at all, was very likely milder and shorter than a near extinction of humankind would demand. So here is where the evidence honestly leaves us, and you deserve the version with nothing smoothed over. The eruption was real and enormous. That has never changed and never will. There was probably some cooling in some regions for some length of time. And our strange genetic sameness is real too. That part was never invented. But the mud says East Africa did not freeze. The ash beds in India and the caves in South Africa are full of people who lived straight through it. And the low genetic diversity that started the whole idea may trace to causes that have nothing to do with Toba over a stretch of time that does not even line up with the eruption. The great volcanic winter that was supposed to have nearly ended us has left no fingerprint in the single best archive that should be holding one. It was not a catastrophe. Stanley Ambrose was not foolish. And this is not a story with a villain. He asked a bold, testable question and built a clean, specific model to answer it. The model simply turned out not to survive contact with the evidence, and the fact that we now know that is the finest thing science ever does to itself, which is the real story hiding inside this one, and it is bigger than a volcano. This was never truly a story about Toba. It is a story about how a satisfying idea can quietly become true in our textbooks long before the proof has arrived, and about how much slow, dull, patient work it takes to unmake it once it has taken hold. Glass shards counted under a microscope, stone tools tallied one at a time in an Indian valley, lake mud read like a book nobody was eager to finish, because the ending was not the thrilling one. The version we fell in love with told us we were the lucky few. The survivors of an apocalypse, the whole of humanity rebuilt from a terrified handful huddled in a cave. The evidence tells us something quieter, and in its own way far prouder. We were more widespread than that. We were more resilient than that. We were across 3 continents at once, simply harder to kill than the story wanted us to be. And the theory that got it wrong was not a failure of science. Someone asked a daring question out loud in a journal, Others walked out into the ash beds and the cave floors and the lake cores and checked it patiently. For 20 years, the answer changed. That is science working exactly as it should. We did not squeeze through Toba's narrow gate because, as far as the mud is willing to tell us, there was never a gate standing there at all. If you want to see more of what the record keeps hidden, click the video on screen now and make sure to subscribe.